All right, guys, we are in lesson 6.2 today. We're still working with systems of equations. This whole unit is going to be about systems of equations. We're going to solve systems of equations in lots of different ways. Yesterday, we solved them by graphing and finding the spot where the two lines intersect on the graph. Today, we're going to solve them without a graph. I might have a graph on one or two slides just to kind of show you the comparison to what we did yesterday. But for the most part, we're going to do these without graphing. Substitution is the simplest form of solving systems of equations without graphs. You know how to substitute already because we do this a lot in pre-algebra. When you know that two quantities are equal to one another, you can substitute them in their place. I realized after I had posted your notes on Google Classroom that I'd left out a couple of examples I intended to be in there. So my first couple of examples here are not in your notes, but they're the simplest examples. So hopefully it won't throw you off too bad. So this will give you kind of a taste of what we're going to do. And then as we move into the other examples that are a little more complex, you'll already have this foundation in place. All right, so use substitution to solve the system of equations. Substitution just means that if two things are equal to the same thing, you can substitute them for one another. So here I have two different equations, and you can see that if I graph them, they've got different slopes, so we know there's one solution, right? We talked about that yesterday. Two different slopes mean one solution. So we know there's one solution, one spot on the graph where these two lines are going to cross. We just have to find it. And we can do that by substituting these two equations for one another. I know that y equals negative 3x plus 7, and y also equals x minus 5. That means I can take this 3x minus 7, and I can put it into this equation right here for y. Because y equals negative 3x plus 7. So here's a y. I can put negative 3x plus 7 in its place. So this really is, it is that simple. I mean, negative 3x plus 7, oops, I put my negative sign in the wrong place. Negative 3x plus 7 equals x minus 5. Now I just solve for x. You guys know how to solve for x. So add 3x. We would get 7 equals 4x minus 5. Then add 5. So 12 equals 4x. Divide by 4. 12 divided by 4 is 3. Oops, 3 does equal 3, but I wanted 3 to equal x. So now 3 equals x. I'm halfway there. I need to know what x equals, but I also need to know what y equals. And so I need to substitute this 3 back into one of these equations, and it doesn't matter which one. I can choose either equation, and I'll get the same answer. So now I'm going to take this 3, and I'm going to substitute it back into this one because this one would be the easiest one to work with, right? So I would do y equals 3 minus 5. So y equals negative 2. Now I'm almost done. These are my solutions. These are my two values, but we're talking about a graph here, right? We're talking about linear equations. I'm talking about a point on a graph where these two lines intersect. And how do we write locations for points on a graph?
3, 2.
We have 3, negative 2. We have to write our solutions as ordered pairs. Okay. That's part of the way we write the answer. If you just leave your answers like this, where you have x equals 3 and y equals negative 2, I'm going to count that off. That'll be minus a point. Okay. You have to write your answers as ordered pairs. Okay. All right, I've got one more example like this before we get into the notes that you'll have. Same thing here. Y equals negative 2x plus 11. Y also equals 2x minus 5. So I can just substitute these two equations in for one another. Negative 2x plus 11 equals 2x minus 5. All right. Add 2x. And does it throw you guys off if I do these both in one step? Hopefully you can follow along there. Subtract 2 or add 2x to this side, add 5 to this side, and then just reciprocate on each side. So that would be 16 equals 2x. Divide by, no, 4x, my bad. I forgot to add the x's. 2x plus 2x is 4x. Thank you for correcting me. Divide by 4, so 16 divided by 4 is 4. 4 equals x. Obviously, if you make it like if I had continued that, had 16 equal 2x, then that throws my x value off, right? Which means my y value then is going to be wrong because I get them wrong. So it compounds your mistakes. If you make a mistake early on, then it throws everything off later. So try to do the math correctly. Now, it doesn't matter which one I use. I can use either one. I'm going to use this one because I like to multiply by a positive instead of a negative. So y equals 2 times 4 minus 5. So y equals 8 minus 5. So then write your answer as an ordered pair, 4, 3. Okay? All right. Now, moving into the next type of equation that we'll face. So now we know what y equals. Y equals 2x plus 1, but I don't have another equation that is equal to y. But I do have a y in this equation, right? And if I know that y equals 2x minus 1, I still can make my substitution. I can put 2x plus 1 right there for y and then solve for x. So all I have to do is I'm going to use this equation to solve 3x plus, now I'm substituting 2x plus 1 in for y, plus 2x plus 1 equals -9. Okay? I can combine like terms. 3x plus 2x is 10x. And then subtract 1. So 10x equals -10. Divide by 10. Oh, it's 5x. Doggone it. Guys, I'm so sorry. Thank you for catching my mistakes. I don't know what's going on with my brain today. I knew I was going to end up with a 10, and I think I'm thinking too far ahead. That would be 5x. 3 plus 2 is 5, not 10. I knew this side needed to end up as 10, so I got carried away, I think. So 5x equals -10. So divide by 5. I'm glad I have the chat where I can see it. Divide by 5, x equals -2. That's better. I got that right, didn't I? Okay. So x equals -2. Now, again, it doesn't matter which one of these I use, but when we end up with this scenario where you have y already by itself on one side, that's always going to be the easiest one to use. When I have y by itself and I know what x is, I can do this in just 1 or 2 simple steps. So y equals 2 times -2 plus 1. Well, 2 times -2 is -4. -4 plus 1 is -3. So y equals -3. So the ordered pair is -2, -3. That's the way the answer has to be written. Okay? All right. Okay. Let's see if I can do this one with no errors. I'm setting the bar high for myself here. Okay? Oh, well, this one has the graph on it. And this is just to show that, there are various ways there. We're going to learn 2 or 3 other ways of solving systems besides graphing and besides substitution. Any way works. Some ways are going to be easier than others depending on the equations that you have, right? These 2 equations would not be that bad to graph. Y equals 2x plus 1. I know my y-intercept is 1 and my slope is 2 for the first one. So that's what this line would look like. Okay, and then for this one, I can get this into slope-intercept form very easily. Subtract 3x from both sides. So y equals -3x minus 9. So now I've got -9 as the y-intercept, and a -3 slope. That's up 3, left 1, up 3, left 1. So there's the spot where the two lines cross. And it's right there where we said it would be. We said on the last slide, the solution was -2, -3. There it is, right? So on some problems, you're going to have, it's just going to say solve the system of equations. And I don't care if you graph it. I don't care if you substitute. I don't care. We're going to add and subtract equations later. We're going to multiply and divide some stuff later. There's lots of different ways to solve systems. Whichever way gets you the solution is the way that I prefer. And I don't, you'll have to do some of each type on the test, of course, because we got to see the skills that you're doing all of them. But if it doesn't specify, then you can do whatever you want to do. All right, let's keep going. Use substitution to solve the system of equations. I know what y equals, 4x minus 6. So now look here where my y is. So when I make my substitution, I have to understand that y is being multiplied by 3. That means I'm going to have to distribute a 3 across some parentheses because I've got to put the y just in this place, right? So it would be 5x plus 3 times 4x minus 6. Okay? Y equals 4x minus 6. So here where the y is at, I can put 4x minus 6 in its place. And then I continue on with the equation equals -1. So all I did was take this and put it in for that y. Now I need to distribute 5x plus 12x plus 12x minus 18 equals -1. Okay? Simplify now. So 5x plus 12x is 17x minus 18 equals -1. Now add 18 to both sides. That would be 17x equals 17. So x equals 1, okay? All right. Why can you not see that? I don't know. I don't know why. On my computer, I can't see all the stuff I just wrote. There we go. That's better. Okay. Now we know what x is, so we can make our substitution to find y. Again, I like this one to substitute. Well, I'll substitute for the x, but I like this one because y is by itself. Y equals 4 times 1 minus 6. So 4 minus 6 is -2. So that would be 1 comma -2. All right. Use substitution. Okay. Same kind of thing going on here. I know what y is. Y is 3x plus 10. There's a y. Why can't I draw? My computer's frozen. My computer is frozen. See if that's better. I was picking up the microphone for both computers, but I can't do anything on my slides right now. Give it a second. Ugh. Lane, can you hear me? Okay, I think I'm back. Sorry guys, I don't know what happened. My computer locked up there for about half a minute and now it seems to be back. So we'll just pretend like it's going to keep working and hopefully it will. Okay, so I've got, yep, it seems to be working. Okay, I've got y equals 3x plus 10. Here's a y in this equation right here, so I can substitute 3x plus 10 in for that y. So 2x plus 5. Sorry, I don't know. I'm evidently having some problems here on this end, and if you're having any internet issues on your end, it's going to be even worse. So hopefully we can make it through. I am recording, I think, as long as I can save it. I'll be able to post this later for you to see. So 2x plus 5 times y, but I'm going to substitute 3x plus 10 in for y. So substitute 3x plus 10. And then it equals -1. So 2x plus 5 times 3 is 15x. 5 times 10 is 50 plus 50 equals -1. There we go. Okay, I'd muted my computer. I couldn't hear anything. Okay, so 2x plus 15x is 17x plus 50 equals -1. Subtract 50. 17x equals -51. Divide by 17. So x equals, that would be -3, I believe. Okay. Now y equals 3x plus 10. I know that x equals -3, so I'm going to substitute in right here for x. Y equals 3 times -3 plus 10. 3 times -3 is -9. -9 plus 10 would be 1. Y equals 1. So -3, comma 1 is our ordered pair. All right, couple more. Stick with me, guys. We're just about there. Now, these are the more complex ones of the problems that we're going to see today. We still can substitute using these, but notice that I don't have any variables by themselves. I don't know what y equals. I don't know what x equals. But I do have an x that is, it's a single x, right? So I can get x by itself very simply. All I have to do is subtract 2y from both sides. So if I do that, and I don't have room here to, if I do -2y and -2y, right? So it's kind of crunched together there, but you know what I'm doing. So that would be x equals -2y plus 6. This is a little different because now I've got x by itself. On all the other examples I've done so far, I've had y by itself first, but it's okay, right? We don't have to start with y. We can start with x. It's okay. I know what x equals. X equals -2y plus 6. So here's an x. I can substitute right there. So that would be 3 times -2y plus 6 minus 4y equals 28. So 3 times -2y would be -6y. 3 times 6 is plus 18 minus 4y equals 28. -6y minus 4y would be -10y plus 18. Goodness, I'm having trouble writing. Equals 28. Subtract 18. -10y equals 10. So y equals -1. All right, now it doesn't matter which one of these I substitute into. I'm probably going to do this one. This one looks like the simpler of the equations. So I thought I switched to blue. So let's do x plus 2 times -1 equals 6. 2 times -1 would be -2 or -2 equals 6. So x equals 8. 8, -1 is our ordered pair. All right, one more example. We're almost there. We're in the home stretch now. Okay, again, I don't start off by having any variables by themselves, but y is a lone y right here. I can make a substitution very easily just by getting y by itself. So add 3x. That would be y equals 3x minus 13. So now I know that y is 3x minus 13. I can substitute into that equation for y right there. So 4x plus 5 times 3x minus 13 equals 11. 4x plus 5 times 3x is 15x. And then 5 times 13 should be 65. So minus 65 equals 11. I'm going to add 65 to both sides. 4x plus 15x is 19x equals 76. Divide by 19, and x is 4. All right, so x is 4. I can substitute into either one of these equations. I'm going to do this one because y is y is a single value already, so I won't have to divide anything at the end. So y minus 3 times 4 equals -13. Y minus 12 equals -13. Add 12, so y equals -1. 4, -1. Whew, we made it. Guys, that was a marathon. Sorry for the technical difficulties that we had along the way. I'm going to stop the recording here. There is an assignment